Welcome, students, to this class. In this class, we deal about a capacitor, which is charging and discharging of a capacitor. But before that, let us summarize some basic points about the last lesson. When we talk about capacitor, in the case of capacitor, we have learned how this capacitor can be stored charge, how this can be stored potential, so how it's also stored energy. When we deal about capacitor, the amount of the capacitor that can be charged, or the maximum charge on the capacitor, will be C times V, V naught, as we have learned. Again, the capacitor can store the potential, and this potential is equal to V naught, which means this value is equal to the terminal potential. That means the capacitor, when fully charged, the potential that the capacitor has will be equal with the terminal potential, which means the potential that we applied. Today we will deal about charging and discharging of a capacitor. The objective of the lesson, when we deal about charging and discharging of a capacitor, you should be able to explain how a capacitor stores charge or charging. Again, how the capacitor can be discharging, or you have to explain how the capacitor can be charged and discharged. This is the first objective. The second objective for this lesson is you have to determine the potential, the charge, and the current at any time t. The third objective that you have here is that to determine the amount of the charge for a given time. This is the objective of the lesson. So we will begin by explaining what is a charging of a capacitor. When we deal about the charging of a capacitor, when we apply a potential source, the potential source that we have applied for this grade level, especially for this unit, is DC power source. When we talk about a DC power source, as we have learned, DC source is a power source that has a constant magnitude. Again, the constant polarity, which means the polarity of the positive and the minus of the terminal will not change with time. So this the larger plate designated by a positive sign, and the shorter are represented by a negative polarity. So the shorter indicate negative, whereas the longer represents a positive polarity. This polarity never be changed with time, which is a constant. The other crazy thing, again, the terminal potential will not be fall down or rise up. So the value of the terminal potential is constant throughout. If we connected this power source with a capacitor, this capacitor has a two-way switch capacitor. The circuit is, if this is 1 and this is 2, this is the switch that we use. Again, this capacitor also connected with a resistor in series. This is a capacitor, where this is resistor and this is a power source. This two-way switch, if connected with the one or this alternative way, in this time this will be out of connection, and the capacitor will be connected with the capacitor. As a result, the capacitor will start to charge, store a charge. The plate of the capacitor that connected with the positive terminal will be charged positively, whereas the plate that connected with a negative polarity will be charged negatively. When the capacitor is charging at this time, we have to remind two basic points. The time that we have to examine, firstly, at t is equal to 0. When the time is t is equal to 0, in this case, which means when the capacitor started to charge current, to start to charge, to started potential, to store in it at t is equal to 0, the current will be maximum. The reason that this max current to be maximum at the beginning, as we have learned, when we connected a capacitor with a power source, the potential difference that we applied at the terminal, this will be exist between the two plates of the capacitor. As a result, the potential difference that exists between the two plates will force the charge to transfer from the plate that connected with the positive polarity to the plate that connected with a negative polarity. As a result, the plate that connected with the positive polarity charged positively, and the plate that connected with the negative polarity will be charged negatively. But the basic thing that we wanted to know here is that when the charge transfer from positive polarity, from the plates that connected with the positive polarity to the plates that connected with the negative polarity, firstly, when the first charge is transferred from the terminal of the plate of the terminal, the plates that connected with the positive polarity to the negative polarity, the first charge when it's transferred from this plate to this plate, there is no force that influence, which means there is only a little force that influences the motion of the electrons. But when we again transfer the second electrons from the plates that connected with the positive polarity to the plates that connected with the negative polarity, there will be attractive force on the plate of this one, and there is also a repulsion force on the negative plate. As a result, as we transfer more and more charges from the positive polarity to the negative polarity connected plates, in this case there will be a larger force. So the force only will be small, which means the resistance will be small only at the beginning. With time, the resistance will increase. This indicates that at the beginning, at t is equal to 0, the current is a maximum. Current means the flow of charge. The ability of the flow of the charge will be maximum at t is equal to 0. Again, when we talk about the potential, again the potential at the beginning will be 0. The reason that the potential at the beginning to be 0 is the capacitor is a neutral capacitor at the beginning. The capacitor doesn't charge it, which means there is no charge on the upper plate and there is no charge in the lower plate. As a result, there is no potential that is stored by the capacitor at is equal to 0, which means just the capacitor began to charge. The charge is also 0, which means there is no charge on the capacitor. As a result, there is no charge. Because of this fact, at t is equal to 0, current is maximum, potential is 0, charge is also will be 0. But at t is equal to infinity. At t is equal to infinity means when we connected the capacitor with the power source and left it for a long time, the capacitor will become to be fully charged. At the time, when the capacitor is fully charged, there is no extra charge that flow from the positive terminal to the negative terminal, which means the plates that connected with the positive polarity to the plates that connected with a negative polarity. There is no flow of charge when the capacitor fully charged. As a result, the current will be 0, which means there is no extra flow of charge. The potential will be V0. The reason that we say V is equal to V0, as we have learned in the last class, when the capacitor is fully charged, the potential of the capacitor will be equal to the potential of the source, because the difference that exists between the two plates as the charge flow from the positive terminal plate to the negative terminal connected plates, the potential will increase with electric field, because the electric potential will be is equal to E times D. D means the separation distance between the two plates, and electric field is the field that exists between the two plates because of the charge that are on the positive charged plate and on the negatively charged plate. This potential E times D must be equal with the terminal potential that is V0. The reason is that the flow of charge stops only when the potential across the plate and the terminal potential are equal. Because this fact, we say when the capacitor is fully charged, the potential will be V0, which is equal to the potential of the power source that we call V terminal. So V terminal will be equal to V0. As a result, the terminal potential and the potential across the capacitor will be equal when the capacitor is fully charged. This is the basic thing that you should realize in your mind. When a capacitor is charged, the charge will flow, and the plates that connected, when this switch comes to connect in this way, and this makes a closed circuit for a capacitor, the potential will be connected with the capacitor. As a result, if the upper plate is positively charged plate, the capacitor of the upper plate will be charged positively. The plates that connected with the lower plate will be charged negatively. So this indicates that when the charge flow at the beginning is equal to 0, which means when the capacitor started to charge the capacitor, the current will be high, which means there is a freedom for electron to transfer from the power source to the plate, which means the charge will transfer from the plates that connected with the positive polarity to the plates that connected with a negative polarity. This resistance will increase because of the attractional force of the positive charged plate and the repulsional force of the negatively charged particle, as electron is a negatively charged carrier. As a result, like charge repel each other and like charge attract each other. When this electron travels from the plate of the positively charged plate to the negatively charged plate, there is a force that pulls the electron back on the positively charged plate, and there is also a repulsion force when the electron moves from the positively charged plate to a negatively charged plate, because there is like charge repulsion. As we have learned, like charge repel each other and like charge attract each other. Because of this fact, the force will increase and reach a maximum. When the potential is also a maximum, there will be no any more flow of charge. As a result, at the beginning there is a maximum current, and finally at t is equal to 0, the current will be 0. It will stop flowing. Again, the charge that we obtain when the capacitor is fully charged, it will be Q0. Theoretically, when we see charging of a capacitor, at the beginning at t is equal to 0, the current is maximum, the potential is 0, the charge is 0. When the capacitor is fully charged, which means R is equal to infinity, when the capacitor gets enough time to fully charge it, the current will be 0, because there is no any more flow of charge. When the capacitor is fully charged, the potential will be equal to the maximum potential. This potential is equal to the power source potential. The charge will be also a maximum, which means at this time the capacitor can store the charge that it can store, or it can store. This is theoretical, but this theoretical value also can be related mathematically. If we see this value with time, we have three types of graphs. The first graph that we think is a current graph. When we talk about current, the value of the current from the maximum value to 0 value, it will decrease and comes to 0. When we plot the current versus time graph, the value of the current during the charging of the capacitor, the current will decay from its maximum value to a 0 value. This equation that we represent this on the graph, as I told you in the last class, that the charging of a capacitor is exponential, has exponential character. As a result, this graph can be represented by I naught multiplied by e to the power minus b over RC, where RC is a time constant. Is a time constant in the SI unit, or in short, the SI unit of time is second. the value of the SI unit of R times C value is also give a time. As a result, we call it the time constant. The graph of current versus time graph for a charging of a capacitor can be represented by this one. Secondly, when we deal about the graph of potential versus time, in this case, in the case of charging of a capacitor, as we can see here, the potential at the beginning is 0, but finally when the potential or when the capacitor is fully charged, the potential will come to V0, which means the total or the maximum potential, and this potential is equal to the power source potential. This indicates that, again, this character is also exponential. Exponentially, the potential will build across the capacitor, and the result it can be drawn just like this one. This value indicates that the maximum V0, which means the potential will build up across the capacitor exponentially. As exponentially it will build up, this comes to the maximum potential. It's approach to the maximum potential. As a result, when the capacitor is fully charged, this value at time is equal to infinity. It will be fully charged. This value will become to a V0 value. Again, when we talk about the charging process or the charge that can be accumulated on the capacitor plate is also exponentially built. This exponential building can be represented by Q0, which is the maximum charge on the capacitor. This charge also started from 0 and approach its maximum value, and at it is equal to infinity. It attains it is a maximum value when the capacitor is fully charged. Again, this is exponentially building graph, exponentially increasing graph. This also exponentially increasing graph. As a result, if it's exponentially increased, this can be represented by is equal to V0 multiplied by 1 minus the power of T over RC for exponentially increasing graph. Again, this can be also represented by Q, which is equal to Q0 1 minus the power of minus T over RC. Again, here is RC is a time constant. Again, here is RC is equal to time constant. So, charging of a capacitor can be represented theoretically at the beginning, all are 0 except the currents. Again, as it is equal to infinity, in charging the current will become to 0 and the potential and the charge will become to a maximum value. So the graph versus time for charging capacitor is this one with this equations can be. Again, the potential versus time graph is also given by this pen. The equation at any time t for the potential can be determined from this equation. Again, the charge at any time t can be determined from this equation. Again, in case of charge versus time graph, it is exponentially building graph. We have these equations. This is about the charging of a capacitor. What will be discharging of a capacitor? You have to remind one basic point. The thing is that you have to remind your mind that when we used a capacitor to store charge, the potential of the capacitor will be equal to the terminal or the source that we applied on the capacitor. So the potential of the capacitor and the potential of the power source will be equal, which means V of terminal, which means the potential of the source is equal to the maximum potential that can be stored on the capacitor. Again, to determine the maximum charge will be equal to the capacitance multiplied by the maximum potential, which means the maximum charge that can be stored. When we talk about here, the maximum charge on charging of a capacitor and the maximum charge that we obtain in discharging of a capacitor are the same. They can be determined by C times V0. The other thing that we have here is that how we describe the discharging of a capacitor. In the case of discharging of a capacitor, there is only two circuit components. These circuit components are only resistor and a capacitor. The potential of the capacitor at the beginning is equal to V0. This can be the positive and the negative plates. And there is a resistance R. When charging and discharging of a capacitor, there is three circuit components. These circuit components are resistor, capacitor, and terminal potential. But in the case of discharging of a capacitor, in the case of discharging of a capacitor, there is only two circuit elements. These elements are resistance and potential. Resistance is used to dissipate the energy that is stored by to energy, which means it converted electric potential energy into light energy or other form of energy. As a result, we have R value. The potential is this potential is the potential that can be stored by a capacitor. When we see the charging and discharging process at T is equal to 0, the capacitor has a maximum potential, and this potential is V0. As we talked here, the potential of the capacitor and the potential of the terminal are equal when the capacitor is fully charged. This potential is a potential that is stored by a capacitor, and this capacitor now ready to discharge it through a resistor. The other basic thing that you should understand or identify here is that when there is a power source in this capacitor connection, the capacitor doesn't discharge its potential through this resistor. There is no loss of energy by the capacitor unless this terminal potential is removed, and only we have the potential source in the resistance. In this case, the potential source that dissipated through the resistor is the potential that is stored by a capacitor. As a result, at t is equal to 0, the potential will be a maximum. Again, the charge will be a maximum charge. But when we talk about, again, the current will be a maximum again. The reason that the current at the beginning to be a maximum, when we charge the capacitor and when the charge is transferred from the plates that connected with the positive terminal to the plates that connected with the negative terminal, this charge is forced to move and overcome the attractional force of the positive terminal on the electron, and the repulsional force of the negative plate on the electron is overcome by this terminal potential or applied potential. If we remove this applied potential, immediately the charge that forced to flow from the positive terminal to negative terminal are ready, or they are immediately flow back to their own original location, or from the negative plate to from negative plate to a positive plate back. The reason is that the removal of this potential. As a result, when we remove this potential source, the flow of electrons will be high because there is a high force that's exerted by like charges, and which means repulsional force between the like charges that are electrons and the attractional force of the positively charged, which means unlike charges attract each other. As a result, the current at is equal to 0 is a maximum. The other basic thing, when we examine this case at t is equal to infinity. At t is equal to infinity means when the capacitor is discharging all its stored. For example, when we connected with a resistor, this capacitor starts to discharge and the electron will flow back to their terminals. As a result, the potential when the charges flow back, the potential upon the capacitor that build that build due to the electric field when the charge accumulates on the positive and negative plates that we thought E times G is equal to V. This potential will be lost because the electric field will become to be zero. As the electrons move back or flow back from negative terminal to positive terminal, the electric field that was built between the two plates will decrease or disappear. As a result, when electric field becomes to be zero, the potential across the capacitor also will be zero. And there is no more any extra charge on the plate that was connected on the negative terminal and the terminal that was connected on the positive terminal. As a result, all the charge will be discharged. So the charge will be zero, the potential will be zero. Again, there will no any flow of charge when the capacitor is discharged. All it is charge and the potential it have. So there is no more charges on the plate, extra charges on the plate. As a result, there is no any flow of charge. So all will be zero. Again, what will be the graph for this case? There is a current versus time graph. The current again, as before, from the maximum value, it will become to a negative value. This process is exponential decaying graph. So the current exponentially decay from the maximum to a zero value. As a result, again, the equation that we use to describe this motion can be given by I0 multiplied by e to the power of t over RC. Again, in the case of discharging is also RC is time constant. This is a time constant. In the second case, we have a potential versus time graph. Again, in the potential time graph, the potential decrease from the maximum value to a zero value. This process is also again exponential. So the potential will decay exponentially from this maximum value to a zero value. This also can be represented by mathematically as V multiplied by is the power of t over RC. This is for potential. Lastly, for the charge, Q naught versus time Q versus time graph. Okay, the potential decay from the maximum value to a zero value exponentially. So it is exponential decay graph. This exponential decay graph can be represented by this equation. Again, the charge will decay exponentially from this maximum value to a zero value. As a result, we obtain Q naught. From Q naught it will be decayed to this value. The charge is also given as exponentially decay, which is Q naught multiplied by is the power of T over RC. This is all about charging and discharging of a capacitor. The first, don't forget it, the first objective that you have to attain on this lesson is that you have to explain charging and discharging of a capacitor. Charging of a capacitor is, firstly, as we have learned, transferring of charge from one plate to another plate, which means the plate from positively connected with the positive plate to the plates that connected with the negative charged plate. The charges that are connected on the plates that connected with the positive terminal are positive charges. So it carries a positive charge. The plates that connected with a negative terminal will be charged negatively. So the two plates have opposite charge, but they have these charges are opposite and equal in magnitude. When we summarize or see this process at is equal to zero, current is maximum, but potential and charges are zero. At is equal to infinity, the current will be zero, but the potential and the charge on the capacitor will be a maximum. So for a long time, if we left the capacitor by connected with the power source, the capacitor will store a potential. That potential is equal to the terminal potential, which means the source potential. Secondly, the charge that can be the capacitor can store also will be a maximum. This can be given by V naught multiplied by C. So in case of charging, the graph of current is look like this one. the potential versus time graph is like this one, and the charge also like this one. In charging, only current have a decay graph or a decay process, but potential and charge have exponentially building graph, so exponentially increasing value. In the case of discharging of a capacitor, at the beginning, the potential are maximum, which means the capacitor stores a potential, which is a maximum potential. Due to this potential, there is a charge that can be stored on the capacitor, and the current or the amplitude of the flow back of electron also high, and the result there is a larger current at the beginning. But if we connect the capacitor through resistor and remove the terminal potential, which means applied potential, the capacitor will act just like a power source. As a result, it will be discharged through this resistor. Again, finally, act is equal to infinity when the capacitor is connected and left with a resistor for a long time. The current will become to zero, which means no extra charge will be exist on the plate of the capacitor. The potential will be zero, and the flow of charge also will be zero. So all the currents, the potential, and the charge will exponentially decay. This is the first thing that we should realize in this class. Okay. When we see charging and discharging of a capacitor, let us see some basic points. Whether this equation that we use to represent this capacitor current, potential, and charge graphs in the equation in the reality that we placed at is equal to 0 and at is equal to infinity for charging of a capacitor. Again, for discharging of a capacitor, there are graphs that are represented here, the equation for these graphs. Again, there is also the realities that we placed at is equal to 0 and at is equal to infinity when the capacitor is discharging. Firstly, at t is equal to 0, at t is equal to 0, which means just begin. For charging, when the capacitor started to charge. For discharging, when the capacitor started to discharge. So, at is equal to 0 if we use current can be represented by V naught multiplied by E the power of T over minus T over RC. This equation indicates that at is equal to 0 for charging of the capacitor. For charging, if we use this formula, I is equal to I naught multiplied by is the power of 0 over RC. If the power of 0 over RC indicates that 0 over RC means 0, if the power of 0 means 1, as a result, I naught multiplied 1 by 1 will be I is equal to I naught. This indicates that at the beginning, the current is a maximum. If we use for a charging, of potential, in the case of potential for charging the process, we have V naught multiplied by 1 minus is the power of minus T over RC. But V naught 1 minus is the power of, in place of T, if we insert the minus, this will be 0 over RC. 0 over RC means 0 over RC means 1, 0, 0 over RC means 0, is the power of 0 means 1. So 1 minus 1 will be 0. As a result, we obtain V naught multiplied by 0. This will be also a 0. So at the beginning, at is equal to 0, the potential is also 0. If we see the charge also given by T naught multiplied by 1 minus is the power of minus T over RC. If we insert in place of T 0, this will be 0 over RC. 0 over RC means 0. 0 is the power of 0 means 1. 1 minus 1 is also 0. This again gives for us T naught multiplied by 0. The result also will be 0. So R is equal to 0 for charging the process. The current will be a maximum current. The potential will be 0. The charge will be 0. What will be at T is equal to infinity for charging of a capacitor? For charging of a capacitor, current is again given by I naught multiplied by is the power of T over RC minus T over RC. As a result, I is equal to I naught multiplied by is a power of negative infinity over RC. Negative infinity over RC. In short, this value gives a value of 0 as t tends to negative infinity over RC. RC is a time constant. This value is a constant value for a given capacitor. As a result, I is equal to I naught will be multiplied by 0. This value will give a 0 value. So at is equal to 0, the current becomes to be a 0 value. But for the case of potential will be V naught multiplied by 1 minus in the power of T over RC. In this case, V will be V naught multiplied by 1 minus is a power of, in place of T, if we insert negative infinity over RC. Again, negative infinity over RC. In the power of negative infinity over RC, this value will become to be 0. If this value is 0, 1 minus 0 is 1. 1 multiplied by V naught will be a V naught. As a result, V is equal to V naught. This indicates that this is also the same for the case of charge. As a result, the charge is also will become to Q1 naught. This indicates that the graphs, the equations, and the initial concept or the initial theoretical aspects are true for charging of a capacitor. What about discharging? In case of discharging, all the current, the potential, and the charge exponentially decrease. If they exponentially decrease, the current is given by I naught multiplied by is a power of T over RC. If we take the time at t is equal to 0, I will be I naught multiplied by is a power of 0 over RC. This value will be 1. The current will be a maximum at the beginning. What about the charge? Charge is also given by, for discharging, Q1 naught multiplied by is a power of minus Q over RC. If we insert 0 in place of T, we obtain Q1 naught is the power of 0 over RC. 0 over RC means 1. 0 over RC means 0 is a power of 0 means 1. As a result, 1 multiplied by Q1 naught, it will be Q1 naught. At the beginning, it is maximum. The other thing, when T is equal to infinity, charge will be equal to Q1 naught multiplied by is a power of T over RC. But Q1 naught is a power of minus infinity over RC. This value is a 0, as we discussed before. If this value is 0, 0 multiplied by Q1 naught, this will be Q1 naught multiplied by 0. As a result, this will be 0. So the equations that we place here, in the graphs, again, the theoretical aspects are related, they are correct. Again, when we see the charging case, the graphs and the equations that we placed are exactly true, or they are related because of this fact. So in this lesson, we have learned about charging and discharging of a capacitor. Charging of a capacitor means transferring of the charge from one plate to another plate. When we connect the capacitor with a potential source, the capacitor will be charged. And if we disconnect the capacitor and replaced by a resistor, or connected the capacitor in series with resistor, it makes the capacitor potential and energy and the charge to be discharged to resistor. This is the main important point that we realized for today. It is much enough. For next class, we will try to see about charging and discharging of a capacitor by connected to each other. It is enough.